Yo, so do you want to know how to solve a simple circuit using supermesh analysis? Then keep watching this video to learn how to.
This eye is not merely seeing reality, it is touching the truth.
So what's up guys, today we're going to solve this problem number 5. So employing the supermesh technique to best advantage, we must obtain the numerical values for each of the mesh currents identified in the circuit depicted in figure 4.71. So what this means is we must find for I1, I2, and I3 using supermesh technique. So to use the supermesh technique, we must find the loop that we must abide using that technique. So as we can see, the only loop that is possible is going from this to this. So this is the only loop that we can use to solve the supermesh technique, which goes from 5 ohms to 3 ohms. And the reason why we could not use the supermesh technique in other paths is because some of these paths have current sources such as this, and this. And the only way to solve a supermesh technique is to have a KVL equation. And to solve the KVL equation, there is only one path for that, which is going from this to this and back to its original position. So let's erase this. So in order to solve for the supermesh technique, we must identify the KVL equation surrounding this loop and then the supermesh equation that we can obtain from this current source and this current source. We must also label this source as an independent loop going around this direction, which is in the clockwise direction. So we'll label that as I4. So I4 is equals to 3 amps. And then we'll also put in this description that we need to find 3 equations for 3 unknowns in order to solve this problem. After that, we then put the values for the KVL equation surrounding this loop. So to do that, you must apply the mesh technique. So to apply the mesh technique, we must first identify our loop. So write in here KVL at super mesh loop, and we'll say this is the super mesh loop number 1. So here we go. This is the KVL super mesh loop number 1. So in the KVL super mesh loop number 1, you can see that it goes or it starts from the 8 volts. The direction of the current is going in this direction. So we're going to identify this as positive 8 volts because the current goes through the positive terminal of the circuit, as we can see in this position. So we'll identify this as positive 8 volt. So we're going to write it over here. So positive 8 volt. And then right next to the positive 8 volt, you could see the negative 2 volt. The current going through here is going to start from the negative, or is going to enter to the negative terminal of the 2 volts. So we're going to write that as negative 2 volt. And then it goes through this 2 ohm resistor. So we're going to write that as the positive 2 ohm resistor. But remember, in order to have a voltage source, you must have a current and also a resistor. And since there is no current, we're gonna label the current as I3 since this is the mesh current going through this direction. So it's going to be I3. Right next to I3 is going to be negative 3 volts since the current is gonna go through this direction, which is going to enter to the negative terminal of the 3 volts. So we're gonna write that as minus or negative 3 volts. Right after that, our pattern continues to go up in this 3 ohm and then back into this 5 ohms. So we're gonna write each of this as positive 3 ohms multiplied by the current source going into this resistor, which is I2, and 3 amps, which is considered as I4. But instead of writing I4, we can directly say that it is going to be I3. And the reason why it's going to be a negative current is because it goes opposite to the direction of I2, which is going up. So we're gonna label that as negative 3 amps. So let's erase this. And let's write 3 ohms multiplied by I2 minus 3 amps. And then, next to 3 amps is going to be next to 3 amps is going to be 5 ohms. So we're gonna write plus 5 ohms multiplied by the current that we are following with, which is I1, minus 3 amps, since I1 is going into this direction, while 3 amps is going opposite this direction. So we're gonna write that as minus 3 amps. So 5 ohms times I1 minus 3 amps, which equates all of this equation to 0. So we're gonna write 0 this equation. So this is our equation right now. Negative 8 volts minus 2 volts and then etc. So after finding out this equation, we will then use simple algebra to simplify this equation. So we will then copy, Ctrl C, then paste. Then we will multiply 2 with I3 and we will get 2I3. We'll then transpose this negative 3 volt into this position. We will multiply 3 with I2, then we will get 3I2. And 3 with negative 3, we get negative 9 volts. Five with I1 and we'll get 5I1. 5 with I3 and we will get negative 15 volt equals to 0. Now we have simplified our equation, but we can still further simplify it by doing the same thing. So we'll move the negative 9 volt, but first we must copy all of this. So we'll move the negative 9 volt together in this position, and also the negative 15 volt. So here we go. Now we'll solve. So positive 8 volt minus 2 volt minus 3 volt minus 9 volt minus 15 volt equates to negative 21 volts. And we'll just copy this. Now we have our equation. The next thing we'll do is we'll arrange this equation so that it follows the traditional arrangement of I1, I2, and I3. And we will also move the negative 21 volts in this position. So adding 21 volts to both sides of the equation, we'll get we'll get 2i3, 3i2, and 5i1 equating to 21 volt. We'll also arrange this. So this is our final equation. I will write this as equation number 1. Equation number 1. So after finding out our equation number 1, we will then solve for 2 equations since we're looking for 3 equations for our 3 unknowns. So let's see. Let's erase this. We can see that we have a super mesh equation in this position and also in this position. I will write it as, zoom out a little bit. I will write it as something like this. Super mesh equation number 1, which is equals to negative I1, since the negative I1 is going to the opposite direction of the current source, and positive I2 since it's going to the same direction as the positive current source. So we'll get negative I1 plus I2 equals to the current going out, which is 1 amp. 1 amp. We'll also write for the supermesh equation number 2. So let's copy this and label it as supermesh equation number 2. Oh, don't forget to write what type or what number of equation is this. This is going to be our equation number 2. So for supermesh equation number 2, we'll write positive I1 since it's going to the direction of the current source, and negative I3 since it's opposing the direction of the current source. So it's going to be positive I1 minus I3 equals to negative 2 amps. We could also write this as negative 2 volts since the volt in this equation, or the value for this equation, is equals to volt. So we'll write it as the unit of volt. So here we go. We now have 3 equations. We have the equation number 1, equation number 2, and equation number 3, which I forgot to write. And I'm sorry for that. Let's write that again. This is our equation number 3. So we now have 3 equations. 1, 2, and 3. So after finding out the 3 equations needed to solve this problem, we can then use the Cramer's rule to identify the unknown values for each current. So we're going to use a calculator to solve this. We're going to type Cramer's rule calculator. And we're going to set it into a 3x3 matrix. Now we're going to type the values for each current. So we have 5, 3, 2, and 21. 5, 3, 2, and 21. We also have negative 1, 1, and 1. Negative 1, 1, and 1. Here, we'll put 0 since there is no value for that. I1 is going to be 1, 1, and negative 2. It's going to be 1, negative 1, and 2. Negative 2. And we're going to put 0 in this since I2 is not indicated in the equation. So we're going to solve. And as we can see, the value for this is going to be 1.4, 2.4, and 3.4. So we're gonna put this in this text. We're gonna write I1 equals 1.4, I2 equals to 2.4, and I3 being 3.4. Well, to identify if our answer is correct, we're gonna use multisim to simulate this circuit and to identify the current flowing through each circuit that we just solved. So, let us remember this answer and compare it to the simulation. So this is the circuit that I built using a multisim, and I copied the circuit design given in the problem, which you can see over here. So let's erase this. So I followed the instructions and I copied the circuit and I identified the current flowing from each of the circuit using a multimeter connected in a series way. So I set the multimeter in direct current and I also set it in ammeter mode. So let's now run this circuit and identify each of the current flowing. So for I1 we have 1.4 amps, for I3 we have 3.4 amps, and for I2 we have 2.4 amps. So this shows that our solution was indeed correct. And as you can see, using mesh loop creates or lets us know what are the currents flowing in each of the resistors. So for I1 we have a current flowing in this way, which is 1.4. For I2 in this way, for 2.4. And for I3, we have a current flowing in this direction for 3.4 amps. So that was it. I hope you've enjoyed my video and I hope you've learned a lot about mesh current analysis. So see you next video.